Welcome back to another installment of our WebGPU triangle video series. At this point, I believe we're on video number 5, so I'm going to skip the introduction a little bit and just say that you can find a link to the code in the description of this video. And if you navigate there, you'll see the code that we've been using as our guide throughout this entire series. And the content of today is pretty exciting because what we'll be looking at is some shader programming. So let's check it out. So if I take this code, then open up VS Code, we'll add in our shader definitions. So what we see here in this code chunk is our vertex shader and our fragment shader. And what we need to use is our GPU device to call this create shader module, and then we just pass in this code. If this is your first time looking at shader code, it could seem a little different, especially if you're coming from JavaScript, for example. Anywho, what's important is that we're going to be going line by line through this code so we can better understand what all of it means. So what exactly are the steps here? So we have this vertex shader here, we have this fragment shader here, and if you're unfamiliar with graphics, you might be saying, what is the relationship between those two things? What we can do is that we can open up our ink space, and I've taken the time to create this graphic in order to help explain exactly what's going on. So if we start on the left, we see we have our application, and I have that in CPU space. So for example, for doing just normal coding in JavaScript, for example, and running an application, it's going to be running on the CPU. But by using device.createShaderModule, we'll be creating shaders that will be running on the GPU. And that's what a shader is exactly. It's just a program that runs on the GPU. Now, the two types of shaders that we're going to be using are the vertex shader and the fragment shader. So, as we all know, a triangle has 3 vertices. So for each vertex, the vertex shader will be executed. So in other terms, the vertex shader will be ran 3 times. For all the circles here, the vertex shader is running for this left circle, this top circle, and this right circle. For each pixel within our triangle, we are going to run this fragment shader to determine what the color is exactly. So as you can see, we're going to be running this fragment shader a lot more times than our vertex shader. So now let's go back into our code. And what I think is important is that we start here with our struct, vertex out. What we're going to do, if we look at this line right here in our vertex shader, is that we are going to create an output variable with the type vertex out. We'll be setting the fields of our struct to ultimately return as an output of the vertex shader. So in order to define a vertex shader, what we need to do is we need to use this keyword right here on line 98, this little arrow bash symbol and vertex. We have this vertex main function. We have 2 arguments here. And the one thing that I really want to call out right in the beginning is that we've talked about these 2 locations, location 0 and location 1 in the previous video. We can actually scroll up here and we can see that in our vertex buffer descriptors that we worked with in the last video, what we did is that for our 2 attributes, position and color, we set these shader locations. And for example, position we set as shader location 0 and color we set at shader location 1. So knowing that, if we scroll down, we can see at shader location 0, like we defined above, we have position, and at shader location 1, we have color. And those, as you can see, are acting as inputs to our vertex shader. So before moving on, it's important to realize a couple things, especially when it comes to a vertex shader. Again, this is going to be super high level, but the one goal of our vertex shader is to calculate the position of a vertex in a scene. And as you can see, this is a very basic vertex shader. There's not much calculation going on. We're passing in the position and we're setting it to this output.position. And then we are just returning the output, which, as we saw before, is this vertex out struct. What's important here is that we have this built-in keyword, and also too, we're passing in position. This is actually not arbitrary, and position is the output position of the current vertex using homogeneous coordinates. Now, what you'll see here is this @location keyword, and we're passing in the number 0. What we're basically doing is defining this color variable to be stored at a location in memory on the GPU. We're saying location 0. That's not important right now, though the big thing, however, is that we are setting this color field to be the color that we passed in from our application, and we are returning the output. Now, looking at our fragment shader, we know that this is going to be running for every pixel within our 3 vertices of our triangle. So the first step here is that we have this @fragment keyword, and that's just saying, hey, I'm defining a fragment shader. And we also have this parameter, our frag data, which is of type vertex out. So, which is pretty neat because, as you can see, the fragment shader is receiving the output of our vertex shader. We'll see why this is important later, but the one thing that's super important, if we look at line 111, is that we are just taking that color data that we passed from the vertex shader and we are returning it. And that's exactly what the job of the fragment shader is that it's returning a color, a vec4 color, and that'll be used to determine the color of the pixel in our scene. So that wraps up this video on vertex and fragment shaders. I'm going to leave a link in the description to a couple blog posts that should help solidify these topics, and I'll see you in the next video.